to the third session on ionic equilibria. This is a continuation of the theories on acids and bases. In this session, we will be dealing with Lewis concept, Lux flood, Usanovich and solvent system concepts of acids and bases. Let us see what is Lewis concept of acids and bases first. An acid is a substance which can accept a pair of electrons. It is easy to remember, acid accepts a pair of electrons and base is a substance which can donate a pair of electrons. Anything which is capable of accepting a pair of electrons, or in short you can say that will be something which is electron deficient. Such compounds are considered as acids, and those which are capable of donating a pair of electrons, they are considered as bases. And here we will be seeing that is this donation and acceptance is the criteria to determine whether a substance is an acid or a base. See, in the case of an acid, it is considered as an electron pair acceptor, and base is an electron pair donor. Okay. Now, here we know these are two molecules, boron trifluoride and ammonia. They combine to form a complex. Now, in this case, you should see what is boron trifluoride. Boron trifluoride is a compound which is electron deficient, because bonding with 3 fluorine atom, boron has 3 electrons and 3 electrons from fluorine atom, you will have altogether 6 electrons, and therefore boron lacks 2 more electrons to form an octet, and therefore boron trifluoride is an electron deficient compound. It is an electron deficient compound, and as a result it needs 2 more electrons, and whereas ammonia, it has got its lone pair which is capable of being donating. So, nitrogen of ammonia donates a pair of electron to boron trifluoride and forms a coordinate bond between nitrogen of ammonia and boron of boron trifluoride. So, this coordinate bond, you can see that it is represented by an arrow mark, where the arrow mark is from nitrogen to boron, which shows that nitrogen donates a pair of electron to boron and forms a coordinate bond. Where coordinate bond is a bond where the electron pair shared by 2 atoms will be donated by a single atom. This is, in this case it is nitrogen. Nitrogen donates a pair of electrons to boron, and they both together share that pair of electron, that is represented by this arrow mark. Now, here boron accepts a pair of electron, and therefore that is an acid, or you can say that it is a Lewis acid, and ammonia donates a pair of electron to boron for forming the coordinate bond, and therefore ammonia is a base. You can call it as Lewis base. First, this is a Lewis acid and the other one is Lewis base, and here we have the complex formed. Now, take the second case where fluoride donates a pair of electron to boron trifluoride, which is, again I told you, it is an electron deficient compound, and it forms a complex with a negative charge on it. So, this is actually the compound BF4, you can call it as compound, it is an ion, BF4 minus. So, in this, fluorine donates a pair of electron, not fluorine, fluoride ion donates a pair of electron to boron, forming BF4 minus. So, here BF3 accepts, and therefore this will be an acid. Fluoride ion donates, and therefore this will be a base. All these based on Lewis concept. Here also, in the case of ammonia, ammonia donates a pair of electron to hydrogen ion. Here the donation is in this direction, and you have the compound NH4 plus. Okay. So, here who donates? Ammonia is donating, and therefore, that will be a base. H plus ion accepts it, therefore, that is an acid. So, this is a Lewis concept of acids and bases, and here it is applied for the compounds which enter into a complex formation. Okay. Now, according to Lewis concept, all cations then are electron deficient compounds and molecules having a central atom with vacant d orbitals, mostly that will be metals, which can accommodate excess electrons than the octet. That is, even though they are having an octet state, they can accommodate their electrons in their vacant d orbital. Such atoms also, and those atoms which form the molecules can act as Lewis acids. They can all accept a pair of electrons. Cations can, electron deficient compounds can, and also those can extend their valency above octet state, that is in their vacant d orbitals. And anions and molecules with lone pair, just like ammonia, and molecules that can form pi or sigma bonds with Lewis bases, form Lewis bases. So, those compounds are considered as Lewis bases. Limitations is that it is too general, which classify almost all species which can form coordinate bonds. Anything which enters into a coordinate bond into acids and bases, that does not look that nice. And again, it is difficult to explain the relative strength of acids and bases. You can't explain their how far. Just donation of an electron and acceptance of electron is the only criteria. We can't compare how far it is acidic or how far it is basic, or you cannot say whether it is more acidic or more basic on this basis. So, we have another concept now, which is known as Lux flood concept of acids and bases. In this, acid is considered as an oxide ion or a negative ion acceptor. Oxide ion acceptor or negative ion acceptor is considered as an acid, while base will be the reverse of that, an oxide ion or a negative ion donor. Okay. So, you can brief it as acid is any substance which is oxide or negative ion acceptor. Oxide is oxygen with its 2 negative valency. Then oxide or negative ion donor will be a base. Let us see some of the examples. Here, calcium oxide reacts with carbon dioxide to give calcium carbonate. Now, what happens is, when these two react, actually this can be considered as Ca2 plus and CO3 2 minus. How does this happen? This calcium oxide donates its O2 minus ion as O2 minus ion to carbon dioxide, and carbon dioxide changes to carbonate ion. Okay. Since calcium oxide loses O2 minus, it will be gaining a 2 plus charge on calcium, and together it becomes calcium carbonate. Now, what happens is calcium oxide donates to carbon dioxide. So, this is a donor. Donor means what is that? It is a base. Carbon dioxide accepts the oxide ion, or you can call that to be an acid. So, carbon dioxide acts as an acid, while calcium oxide acts as a base. It does not have any H plus ions or OH minus ions. Still, we are classifying this as an acid or a base, that is based on Lux flood theory. Okay. Now, let us consider this one, that is sodium fluoride and aluminum fluoride reacting together to give sodium aluminum fluoride. I will put it as Na plus 3 times and Al F6 3 minus. Okay. Now what happens here? This is actually this compound. I have written it just to show you that here one of the sodium fluoride transfers its fluoride ion to aluminum fluoride. Like that we have 3 fluoride ions being donated from 3 sodium fluoride to aluminum fluoride, and that becomes, this is fluoride ion being donated, not oxide ion. Okay. So 3 of them get donated here, and this becomes AlF6. Since 3 fluoride ions come to it, it becomes 3 minus. Since each of the sodium ion loses 1 fluoride ion, it becomes Na plus, and like that we have 3 sodium ions, and that compound is written as Na3AlF6. Now in this case, oxide ion is not donated. Here donation takes place of a negative ion and accepts a negative ion. Got it? So negative ion acceptor, who accepted it? Aluminum fluoride, and therefore that is an acid. Sodium fluoride donates it, and therefore sodium fluoride is acting as a base. Hope it is clear. So it can be either an oxide ion donation or acceptor, or it can be any negative ion being donated or accepted. In both cases you can classify whether it is an acid or a base. Now what are the limitations of this theory? All acid base reactions are considered in terms of anion transfer, and it is applicable only to ionic reactions, because in only that we will have anions and all. Anions and cations, they come in ionic reactions. So this is applicable only for ionic reactions. So in other cases we can't classify whether it is an acid or a base. It is neither convenient as the proton concept, nor it is as general as Lewis concept. So it has got only very limited applications. So we are moving to another theory, Usanovich concept of acids and bases. This is somewhat a broader theory in which we will be comprising most of the concept which we have seen earlier. Here acid is considered as any substance that produces or gives up cations, takes up anions or electrons, or reacts with bases to form salts. Okay? And base is any substance that gives up anions or electrons, takes up cations, or reacts with acids to form salts. So this is a broader concept in which we can have acid can be considered as a cation donor or an anion acceptor, an electron acceptor, or any which neutralizes a base. Okay. Now in the case of base, it is an anion donor, the reverse of that, cation acceptor, an electron donor, or one which neutralizes an acid. Now let us see the examples. Here you can see that it is HCl reacting with ammonia. When HCl reacts with ammonia, what happens is, we have already seen this reaction. Here HCl donates an H plus ion to form ammonium ion, and chloride ion is formed. Here actually this is written as ammonium chloride, but actually you can put it as NH4Cl. To make it clear, I have just split it into ions to see that H plus ion is donated from HCl to ammonia to form an ammonium ion. Now here we have the concept told that here H plus, which is a cation, this is a cation because it is positively charged. You can see that a cation donor, what is that? It is an acid. So HCl is an acid. According to base concept, it is anion donor or a cation acceptor. So it has to accept a cation. Now ammonia accepts a cation, and therefore this acts as a base, and you get the salt ammonium chloride. Okay. Now here, calcium oxide reacts with carbon dioxide to give calcium carbonate. Here what happens is this calcium oxide donates its oxide ion. Oxide ion, again this is negatively charged and therefore that is considered as an anion. Okay. So, one who donates an anion, who is that? Anion donor. You can see here, it is an anion donor means that is a base, calcium oxide is a base. And an anion acceptor, that is the second concept here, see, that is an acid. So, this is carbon dioxide is acid and calcium oxide is a base, both together reacts to give calcium carbonate, in which calcium attains a 2 plus charge, it becomes calcium 2 plus ion because it donates O2 minus to carbon dioxide, and this carbon dioxide accepts O2 minus. So, the number of oxygen atom increases to now 3 with the 2 negative signs on it. So, that becomes a carbonate ion and both together is written as calcium carbonate. Now, here we have a reaction between magnesium and fluorine. What is happening here? When magnesium combines with fluoride ion, it donates 2 electrons. 2 electrons to 2 fluorine atoms, and it will be fluoride ions twice because each fluorine atom takes up 1 electron and therefore, you are having 2 fluorine atoms and therefore, you will have 2 fluoride ions formed. Okay. Magnesium loses 2 electrons. What will happen to magnesium now? It will carry a 2 plus charge. Now, what happened here is neither a cation or an anion, but here it is the donation and acceptance of an electron. Now, let us see what is that case. Electron acceptor is an acid. Electron acceptor is an acid. Who accepted it? Fluorine atom, and therefore, this is an acid. Magnesium donates, and electron donor is a base. So, that is a concept. Now, here according to this concept, it is a broader one in which it can be either a cation donor or cation acceptor. It can be an anion donor or an electron donor or an electron acceptor or a anion acceptor. So, depending on that, you can classify any substance or in any reaction whether it is who will be an acid and who will be an acid base and what will be the reaction formed. Okay. Now, what happens is it also has got some limitations, that is Usenovich concept encompasses all the substance as acids and bases. So, it is very general because any reaction can be considered as an acid base reaction, but that is not the true, and therefore, it is not that useful to be considered. Another thing is almost all reactions are considered as acid base reactions because we do not have any other reaction like redox reactions or anything else, but every reaction will be classified under acid base reaction because in most of the reactions there will be either a donation or acceptance of any of these category. Okay. So, we all move on to the next concept, that is solvent system concept of acids and bases. So, since from the name itself it is considered with a solvent. Okay. Now, an acid is considered as a species which increases the concentration of cation of characteristic of that solvent. It cannot increase any cation, but cation characteristic of that solvent. Okay. If you add something to a solvent and if that solvent's cation concentration is increasing, you can call that to be an acid. Instead, if we add a substance and we find that there is an increase in concentration of the anion characteristic of that solvent, we call that to be a base. It is very important, it should be characteristic of that solvent. Okay. Now, let us see we usually consider the solvent as water, because most of the solutions are prepared in water. So, we have aqueous solutions, and let us see what is the auto ionization of water. Water molecule combines with another water molecule to form H3O plus ions and OH minus ions. Okay. So, this is the auto ionization of water, in which we have H3O plus. What is that? That is a cation. And OH minus ion is the anion of the solvent. It is none other, it is the ions of the solvent itself. Now, if I add anything to water, and if cation concentration is keeping on increasing, means that the substance which we added is an acid. And if I add any other substance, and if its anion concentration, that is a concentration of OH minus ions are increasing, okay, such substances are considered as a base. Let us take an example. Suppose I am adding HCl to water. Okay. What will happen? H plus ions will be taken up by water. You have H3O plus ion formed plus Cl minus. Now, when HCl is added, you have the concentration of H3O plus increased, because the HCl, the H plus ion, protonates water molecule and converts that into more of H3O plus. So, the concentration of cation is increasing, that is, cation is H3O plus ion. This is the cation of the solvent. This increases means HCl is an acid. Hope it is clear. Now, suppose if I am adding ammonia to water, what will happen? Ammonia gets protonated, it becomes NH4 plus what will happen? The OH ion minus will be left out. Here you can see, here you have two ions, there is a cation as well as an anion, but this NH4 plus, it is not characteristic of the solvent. NH4 is not present in the, it is not a solvent cation, but OH minus, you can see that it is characteristic of the solvent, and this anion, this is the anion whose concentration is increasing, and this is characteristic of the solvent, and therefore, increase in concentration of OH minus, that is increase in concentration of the anion. Okay. When the concentration of anion is increasing means we call that substance to be a base. Hope it is clear. You should be, that is, when the reaction takes place, you will have both cation and anion formed from that substance when we add it to water. See, for HCl you are having a cation as well as an anion, but the anion which is characteristic of the solvent, if it is present, that means the concentration of that is increasing, because you will get, that is, water will be having its own cations. In addition to that, you will have additional cations coming from HCl added to it, that is H3O plus ions. The cation concentration is increasing. In the case of ammonia, when we add to water, you can see there is OH minus ions which come from ammonia being reacting with water, and therefore, the concentration of OH minus ions in water increases, and therefore, that is a base. Okay. Now, let us consider, when we consider ammonia as a solvent. Okay. So, let us find out, that is, you are having ammonia auto ionization, in which we have ammonium ion, that is, one of the ammonia molecule gets protonated, it loses one proton, it becomes NH2 minus. Okay. Now, suppose we will see one example. I am adding HCl to ammonia. What will be the result? HCl protonates ammonia, it forms ammonium ion. Okay. That is, this proton goes to ammonia, and what will be left out? There will be a chloride ion. So, here also you have a cation as well as an anion, but anion is not found in the solvent. So, we can discard that. We consider the cation because that is present in the solvent. Here the solvent is ammonia. Okay. So, when we add HCl, the concentration of NH4 plus, which is the cation of the solvent, it is increasing. So, what is HCl now? Since cation concentration is increasing, that is an acid. So, HCl is an acid. You can add any metallic hydride, like if I am taking sodium hydride for example, it will have an hydride ion. I am not going to take Na because that does not look nice in the equation. You add that to ammonia. Okay. What happens is it becomes NH2 minus, that is it abstracts one of the proton and it becomes hydrogen gas. Got it? And here you can see that you have a cation and this is neutral. So, you have a, sorry, not a cation, you have an anion. Okay. Now, this anion, just check, it is present in the ionization of the solvent. So, if I add any hydride, any ionic hydrides to ammonia, there will be an increase in anion of NH2 minus. So, what is this hydride now, or any metallic hydrides? You can consider that to be a base, because adding any metallic hydrides or ionic hydrides to ammonia increases the concentration of NH2 minus, and that is the anion of the solvent, and therefore, that is a base. Now, again the limitations. Based on autoionization of the solvent and reactions that occur between the species and the solvent, it is based only on that. So, we can consider only those reactions in which we have a solvent, and that solvent should be capable of autoionization. It is applicable only to such systems. Can't account for acid base reactions occurring in non-ionizing solvents. What is that? You can take carbon tetrachloride, benzene, chloroform, etc. These solvents do not ionize. They are non-polar solvents, and therefore, in such cases you cannot define an acid or a base, or what is an acid base reaction in such solvents. Okay. So, to conclude, in this session we have been dealing with Lewis concept of acids and bases, Lux flood concept of acids and bases, Usanovich concept of acids and bases, and finally the solvent system concepts of acids and bases. Thank you.